Let's begin our exploration of file concepts, specifically focusing on understanding file systems within operating systems. In this session, we'll cover file attributes, which describe the characteristics of a file. Then we'll discuss various file types, exploring the different kinds of files you might encounter. Next, we'll examine essential file operations, such as creating, reading, and writing files. Finally, we'll dive into file organization, understanding how data is structured and stored within files. Now let's discuss common file types. First, we have regular files. These are the most common type, containing user or program data. This data can be in the form of text, binary code, documents, images, and more. Next, we have directories. These are special files that don't store data directly, but contain references to other files and directories, organizing the file system. Character special files are used for input and output operations with character devices like terminals and printers, handling data one character at a time. Then we have block special files, which are used for input and output operations with block devices such as hard disks and USB drives, transferring data in blocks. Symbolic links are references to other files, working similarly to shortcuts or aliases, pointing to the location of another file or directory. And lastly, named pipes, also known as FIFOs, are special files used for inter-process communication, enabling different processes to exchange data. Now let's move on to basic file operations. The first operation is create. This involves creating a new file within the file system. Here's an example in C. File pointer file equals fopen, with the file name example.txt, and mode W, which means write. Next, we have the open operation. Opening an existing file is essential for reading or writing its contents. Here's the C code. File pointer file equals fopen, with the file name example.txt, and mode R, which means read. Read is another essential operation that involves extracting data from an open file. For example, character buffer of size 100, Fred, buffer, 100, file. Finally, the write operation involves writing data to an open file. For example, character data equals to hello world. Frite data 1 strlen data, file. Let's explore file organization methods, specifically looking at how data is structured within files. There are several common methods to consider. First, there is heap file organization, where records are placed wherever there is available space without any specific order. Heap file organization is fast for insertions, as new records are simply appended to the end of the file. However, it's slow for retrievals because a full scan of the file may be necessary to find specific records. It is, however, simple to implement. Next, we have sequential file organization, where records are stored in a specific order based on a key field. It is efficient for sequential processing and batch operations, but requires reorganization after many updates to maintain the correct order. After that, index file organization uses an index structure to quickly locate records. This method allows for fast retrieval by key value and supports multiple access paths, but requires additional storage for the indexes. Finally, hashed file organization uses a hash function to determine the location of each record. This offers very fast direct access, but is less effective for range queries or sequential access, and may require strategies for collision resolution when different records hash to the same location. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.